Wow, good morning. So as you've just heard, my name's Nathan, and I work at a company called Turnitin. We're an ed tech company. We specialize in plagiarism detection and assisting students with the writing process. And I've been using Go there since the start of 2013, so yeah, just a bit over 6 years. And in that time, I've built microservices, I've built monoliths, I've built command line tools, all in Go, shipped all those to a variety of different platforms and environments. I live in the northeast of England. I'm an active member of the local Go community there and a co-organizer of the local Go meetup. And today I want to talk to us about the incredible Go community. And I want to focus on an area where I think we can make things a little better. We can improve a little bit as a community. We can be more welcoming to newcomers. I want to talk about libraries and what we recommend to newcomers. So this advice appears to be fairly common in our community. So, quickly, by show of hands, who has ever seen, heard, or received this advice when they've asked how to do something in Go? Yeah. Okay. Okay, again, by show of hands, who's ever given this advice when they've been asked how to do something in Go? Yeah, me too. Okay, so by show of hands then, who actually only ever uses the Go standard library? Really? Okay, that's interesting though, right? There's like, quite a few of us have seen this advice. Okay, quite a few of us have received this advice. Quite a few of us have given this advice, but in honesty, none of us really follow this advice completely. But I would say the fact that we can even consider giving this advice shows how incredible the Go standard library actually is. We're all aware that it covers much of what we want to achieve and provides the tools to readily achieve pretty much everything else. But I would say this is terrible advice. And the reason I think this is bad advice is because, for me, the strength of Go is not the language. The strength of Go is its community. And I've worked in many languages over many years, and I've not encountered a single one with a community as good as the Go community. I believe that the Go community is one that is discovering its passions together, it's pulling together in the same direction to deliver something truly incredible. It's a really awesome community. It's full of passionate people who are really helpful, people who love to take time out to help others and to help each other learn and grow. And that's what makes Go more than just a great programming language. Yet the advice, just use the standard library, whether we mean to or not, can put a barrier up between those in the community and those looking to join. Now, I should make it clear at this point, I do love the Go standard library. This talk is not supposed to be taken as a criticism of it or a bashing of it in any way. Like I say, I personally love the Go standard library. Rather, what I want to talk to us about is finding a technical way that we can make the community even better than it is right now. So I should also make clear at the outset that I think it's useful for newcomers to learn the basics, to understand at least a little bit of the code that they're going to be using in other libraries. Like, I wouldn't want any new developer just relying on the magic code of others without like a passing understanding of how it works. So the aim of my talk here is to get us all thinking more about the libraries we use and how we can recommend that, how we can share that knowledge with people who are coming in to Go for the first time. So I'll be illustrating my point with some specific libraries. But the aim is not to recommend to you these libraries necessarily. The aim is really to show that in recommending libraries, we can give more welcoming, more friendly advice to newcomers. Would like to address the question of why care, though. Why bother? Well, this random selection of images from conferences around the world sort of answers that question. It's diversity and it's inclusivity. So with a diverse community, we get a more all-encompassing view of any problem. Solutions come about from combining the highs and lows of past experience. The benefit of a more diverse community is a greater knowledge share. We can learn from the different solutions of other industries. We can develop a more holistic approach to our problem solving. We can find better ways of working together. I think being community-centric has served Go really well so far, and I think it's going to be key to the ongoing success of the language. An easy way for all of us to contribute to this is to just share our knowledge with newcomers. So when we think of our experience in Go and our journey so far, it's the helpfulness of others that has got us to stay. So I think about this is true for me. I came for the concurrency, and I've stayed for the community. And I think this is true for many of us. We come to Go because of the promises of the language, but we stay and get involved because the community is so great and so welcoming. But it's now up to us to make sure that those who come for whatever language-based reason in the future also stay because of the community. And the simplest way we can do this is by giving helpful advice, making useful, actionable recommendations that people can move forward with easily. So what I'm going to do now is demonstrate from some experience some of the better, more welcoming options we could provide when asked how to do anything in Go. I'm just going to get a quick drink. These are the broad headings I've encountered the just use the standard library advice under the most. And when I say encountered, I mean again that I've received the advice, I've given the advice, I've seen it around and, like I say, sadly given it to many people in all three of these areas. Now, for each of these, I'll show some code using just the standard library, and then some code using a library that we use at Turnitin. And hopefully this will illustrate my point, and we can kind of move forward together as we sort of think about being more friendly and more welcoming to newcomers. So let's start with routing. Well, this is really just one piece of the build a web app, build a microservice kind of puzzle. And it's also where just use the standard library advice still appears somewhat common. And I know that Mark Bates gave a talk a couple of years ago at GopherCon UK on not saying just use the standard library when people ask for a web framework. And he built Buffalo for that reason, and that's a great tool, and his talk is fantastic. I'm not going to try and repeat it in any way. I'd recommend you check it out. It's a great talk and really helpful. I just want to look at one specific piece of that puzzle. I want to look at one that's common across web apps and microservices. Let's looking at routing, and typically as a community, we shy away from DSLs, we shy away from frameworks, and so our advice tends to lean in that direction too. However, I don't think we need to be as extreme as saying just use the standard library. Rather, we can recommend the libraries we use or the libraries we have written, and then we can give people a simpler way into the language. So if we take a look at routing, that's sort of visible. This is pretty simple and easy to follow, and you can see what the endpoints are here fairly easily. You can see what functions they map to. But if we take a look inside one of these handlers, and no judging the code particularly, it's very simplistic, sort of on purpose. But we can already see there are issues with this. We're splitting the path to find out what's on the end of it. That's pretty buggy at best. If you had not enough path parts, you'd panic if you left code like this now. Hopefully no one here would ever actually push anything like this to production and leave it like that. But it sort of serves the point of showing that there are problems in the way you do this. The code can become more complex. But it highlights the potential for collisions in your paths really easily. So you could have a path like name/location, and then you could put a single variable on the end of it. Or you can have name/location age, and these can match to the same endpoint. Whereas the second path, maybe it should be rejected as a bad request if whatever that variable wasn't actually found. Worse still, you could have the first one there, name, location, with two variables on the end of it, and you still get a clash with the second one. So you can handle that in code. Yeah, you can return a 400, you can assess what's in the what's been passed in and all that sort of stuff, but it can get confusing for the user, it can get puzzling in your logs, and it makes the code in the actual handlers a lot more complex than it actually needs to be. So the code becomes harder to write, it becomes harder to read, and it becomes more difficult to maintain. So I'd ask the question, is this how we would expect newcomers to the language to develop their apps? I think that's going to make the language a fairly hard sell for some people. Also, the handler itself is HTTP verb agnostic. So that, I would argue, makes the handler code more complex again, makes the definitions of the routes less clear. So you can see here, we can add a way of handling the verbs, that's fine. You can put a switch statement in or an if statement like this example. But you're possibly adding that into every handler. And to handle the values supplied in the path, as we've said, gets tricky. There could be variable numbers of them. Each of those has to be checked. You have to check the types. It adds a lot of extra code, a lot of complexity to the process. And in its simplest form, you end up putting all your variables at the end of a base path, which is not really very restful and feels kind of funky to work with. So suggesting that newcomers to Go use only this kind of puts them off. And I know when I first wrote an API in Go and I was using just the standard library, I found this really kind of unsatisfying. It sort of put me off a bit. But then I found HTTP router. I realized there is a better way. what's powerful here is the introduction of the router is simple. There's nothing more complex than what we had before. We can now more readily see what the paths are and what verbs we support. Under this approach, each verb has its own handler. I'd sort of recommend that approach. It keeps your roots clear. It keeps everything fairly obvious when you glance at it. Yet we've not really introduced any complexity into the setup of the application or the definition of the roots. Well, we should be recommending libraries that add that flexibility and that robustness without any noticeable increase in complexity. That's a really powerful combination and a great tip for people new to the language. As a quick aside here, the placing of the verb in the handler name right at the end there, that's something we've just started doing at Turnitin, because then when we're deep in the handler code, away from the roots, we know what verb we're dealing with because the function name kind of just tells us. And then inside those handlers, we have some code. And we've already seen how each verb can have a distinct handler. And we've seen how we can have paths with variables within them. This just shows us how easy it is to handle those variables, but it also demonstrates that we've reduced collisions and the paths are now much more restful. This feels much more like a proper REST API. So recommending a router can help someone get on with the application they're building, providing for a very simple way to keep some simple structure, just that, keep it simple, makes the language much more inviting. Now, we as a community then benefit from the new perspective brought by those joining the community. Once they've got their structure up and running, they'll work on the specific logic for their business domain, for their problem at hand. And that knowledge then gets shared with the rest of us, and the community learns and grows as a result. So some of the key benefits we get from this package are it's very easy to use. You get very clear root definitions, which is a big win. You get some named path components, which makes handling your roots easier. And you get verb-specific paths. So for the newcomer, knowing how to define roots like this makes the language more enticing. Many other languages, like Ruby and Python, have well-defined routers like this. So recommending a good routing package actually removes a barrier or obstacle, and it enables anyone new to Go to move forward with Go more readily, and they're then more likely to join the community. So let's move on to logging, another area where I think we can recommend a package. So here's some simple standard library-only logging. There's some structure here, and it might be that this is good enough for that sort of throwaway tool, that thing you just have to run today to get something done. You get to see some insight into what's going on. But for a full production app, it's not really enough. So at this point, we have some more complex logging, messages that contain some information. But the output shown here may look okay in this simple example. But imagine a more complex algorithm with logging throughout. Imagine these littered throughout a function. It's pretty easy to see how over time the original content, the original data just gets lost or gets changed. The trouble with this is that when you come to use the logs, it makes it more complex. It makes it more complex to search. The formatting and the contents of any message is basically entirely up to the engineer that wrote that message. So if you picture the scene, your PagerDuty, your Ops Genie, whatever alerting thing goes off, and it's like 3 o'clock in the morning. You wake up bleary-eyed. You have no idea what's happened. It's your service. You're responsible. You start grabbing the logs. But this inevitable lack of log structure makes it nigh on impossible to find anything useful. Also, this kind of output's not super useful in tools like Logstash or Splunk or other sort of aggregators. I would say the final limitation we have is that we really only have print, fatal, and panic available to us. And often we want more subtle logging levels. So there's got to be a better way, something better we could recommend. Well, enter Logrus. It provides a number of added benefits whilst remaining simple to use. And that's the combination that makes it a really useful tip for newcomers. So this little snippet demonstrates how simple it is to set up and use. There's nothing more complex in here than we had before, really. There's nothing to raise a barrier to entry. But the results of this improve the service being deployed and monitored. It's easier for newcomers to adopt the language with confidence in their scenario. Using the functions that are supplied by this library, we get well-ordered, well-structured, consistent output that we can then grep through, we can parse, we can use within a log aggregator really easily. And we actually use this sort of thing at Turnitin, either inline or as a return. In a function, we might just return a Logrus entry. This is what we've termed a custom logger. And the advantage here is that we now know that anything we log with this logger has all these fields and all this data in it. And importantly, we can then rely on the field names, which is really helpful. And because we're using structured logger with JSON output, it's become really easy to work with, and having this consistency means we can know that our logs contain all the useful information we require. So these log lines both have all the fields we saw on the previous slide. We haven't had to repeat them at all, they're just in there now. Well, grepping for these details at 3 a.m. when you're bleary-eyed and PagerDuty has woken you up is much more reliable. So developing loggers like this has become second nature to us as a team. So if I was to add logging and not use a custom logger, or if I was to start throwing values and messages, values and fields in the message at the end, my code review definitely wouldn't pass. There'd be all sorts of red checks all over that, like get into using a custom logger, because we found this approach to be really beneficial and really powerful for us. Also, I'd say that you can add the logger into the context, which means any handlers or functions within the app that receive the context can extract the logger from it and start using it. Well, that gives us great consistency across an entire workflow, or even across a whole application. So when newcomers are trying to promote Go as a language in their scenario or in their company, this sort of ability really helps them to make their case. And we need to use a library for this sort of logging. I don't think it's readily available or readily possible using just the standard library. So some of the key benefits we've got from using this package, again, it's very easy to set up, but we get the structured output, we get structured logs. It's got a clear interface to work with, which makes it really easy to use. It has those useful convenience methods for us. And as I say, we can put it in the context, making it available across a whole application. So for the newcomer, knowing instantly how to get this makes the language more enticing. If they're coming from a log4j world and want easy structured logging, for example, being told just use the standard library actually puts up a barrier. It makes them less likely to get involved. Or recommending a good logging package actually removes that obstacle from their way and enables them to move forward with the adoption of Go. So as they adopt Go, they then bring their business knowledge, their experience and background with them. The community then potentially gets a new field of work involved, and we can all then grow and learn from all the information and the understanding they bring as they look to solve their problems. So the final area that I've seen this under is testing. Now, this one's slightly more contentious because testing is one area where the standard library does provide for us really excellently, and the just use the standard library advice really works and still remains pretty welcoming. However, while I've taken time to change my mind on this one, I have changed my mind in recent times, and I now think there are certain libraries that in certain situations we can recommend people use. We can write our tests, as I say, using nothing but the standard library, and there are clear benefits to that. You know, it reads just like normal code. There's no DSL you have to learn. You don't have to figure anything new out. You're just writing Go code, and that is fantastic. But I think there are some downsides, and next up we'll look at some real-world tests using the standard library only, and then a couple of libraries we found really helpful. And while I hope you find the specifics helpful, the aim, once again, is not to say you should use these libraries. The aim is to just show that actually we can recommend libraries and it can be more welcoming to people. So this is just a snippet of some of our older tests. I stress older. Now, we're comparing values here that were passed into a save function with values we read after the save completed. It's pretty old code, and we check every value on the object. Well, the full set of compares here is actually 18 lines long, not counting the error check. Now, I used to love this approach. I think it's clear, I think it's obvious, but it's painfully verbose. I mean, adding to this, say adding new fields that you're checking, is very, very easy. It's very simple, but it sort of makes the code less readable over time. And I came from a Java world originally, and JUnit was the tool of choice there back in the day. I don't know if it still is, it's been a while, but I thought that the Go approach at the time was a breath of fresh air. But the verbosity of it over time has just sort of started to get me down. Well, then a good friend of mine recommended Testify, and this provides a number of really powerful features when it comes to testing. I'm just going to scratch the surface of that a little bit, really. So we can use the assert package from Testify, and I can cut down the code of those previous checks from 18 lines to 6. Yeah, I haven't lost any of the clarity. The behavior is still obvious. It's still straightforward as to what's happening here. I can use the require function there to handle any error, and that remains clear and concise. So our update provider function can return an error, and we want to abandon abandon the test if the error occurs. Well, using require.nil, we just pass in the testing object, we pass in the error, and that takes care of it for us. It's amazingly concise, yet it contains all of the clarity and all of the information that we had before. The Testify library also has some excellent packages for mocking, allowing you to mock your interfaces. Well, the benefit of mocking, obviously, is that your tests then focus on exercising the code under test and not sort of other things. Now, of course, thanks to interfaces and thanks to simple dependency injection in Go, you can do mocking completely with the standard library. You don't necessarily need a package to do it for you. But what I think this gives us is it simplifies the tracking of what's being called and when it's being called, but it remains simple and clear and easy to read. So you simply embed the mock.mock object on the struct that you're working with, and then you implement the interface you wish to mock. So a simple implementation of the interface allows you to not worry about the details of what's going on. And you can simply check then that the code under test is calling this correctly, is dealing with the responses from this correctly under a variety of different circumstances. The mock object can then be passed into whatever function or other object needs it. And once the function under test is completed, you just assert the expectations. And then you find out whether the calls you've defined as expected have actually happened or not. Have they happened the right number of times? Well, offering this level of testing to newcomers to the community is actually really inviting. For many other languages, this is fairly standard and fairly widely used. So I feel like let's stop trying to get people to use the standard library only to achieve this when we can advise them to use something that covers it for them. Now, HTTP testing, this is kind of testing your interactions with other external HTTP services. Now, not specifically an area I've seen much of the just use the standard library, more an extension of testing generally. I just wanted to put this one in because there's some good libraries here. It is also an area where the standard library does provide for us excellently. Like better than any other language I've worked in, the Go standard library covers this really, really well. But there are third-party libraries that offer us a little more simplicity. Libraries that build on the foundation of the standard library and provide us with simple interfaces to improve our testing. So imagine we have a small function called Retry Fetcher. It's very simple. All it does is it fetches a URL until it receives a 200 or a max number of attempts has been reached, and then it returns the error. So this example here is using HTTP test, which is a powerful and simple to use package provided as part of the standard library. Well, this can be really good for checking the code handles a particular response correctly. Now, we set up the test server here, and each time we hit that server, we hit the endpoint, we increment a counter, and we return a 404. Well, that just means that when we run the code, what's going to happen is it's going to return a 404 every time, reach the maximum number of attempts, and abort, returning that final 404. But this is already fairly long, and we're not actually checking the expectations here at all in any way. Just, you've got to make code fit a slide, I suppose. But enter HTTP mock. Now, this package combines some of the concepts of HTTP test with some of those of testify mock. And to be clear, the guy that wrote this, Dan, is a good friend and colleague at Turnitin, and he open sourced this package when we were starting to need to test more and more of this external HTTP services. But here we test the same retry fetcher code, and in pretty much the same amount of code as before, we're covering the setup and the testing. Now, to me, I find this very neat. It's, I think, very easy to understand and fairly simple to implement. Now, further, this server can then have any number of handlers defined on it, making it really useful in checking what endpoints your code actually is calling at any given time. But the server that you get from this then behaves as you would expect. You get the URL that you can pass into a function or an object that you're testing. The real power of this library comes when you have that more complex set of HTTP requests going on, more fetching expectations. Then you can use it to create a more full-featured server that supports like tracking the number of calls, responding to different request types, different HTTP verbs. You can handle all of that very, very easily with this library. It's simple to return specific body contents, specific response types. And also, like testify mock, you can specify how many times a particular handler should have been hit. And then you can just check, did that happen? Did I hit this handler 5 times, for example? So providing a newcomer with this level of testing opens up the possibilities of what they can confidently achieve with Go, making them more likely to join the community and feed back into it. So these two packages have been widely used across our code base now. And as I said before, it's an area where I remained a proponent of the standard library-only philosophy. But recently, I've changed my mind. And in making the change, tests are now quicker to write, they're quicker to read, and quicker to understand. And obviously, speed of reading code is very important. So I think we can change the advice and recommend third-party libraries. They can make the language more inviting, which in turn makes the community more welcoming. So using libraries addresses early hurdles in app development. It allows you to quickly overcome the structural parts of a system and move on to developing the business logic needed to solve the problem at hand. So recommend libraries. Look over what libraries you use and why. Then share that information with others. Look at parts of your code that's not company intellectual property. Open source it, even if you think it's too niche, it's too much for our domain. If it's not protected, open source it. This is a move we're slowly pushing toward at Turnitin. Giving a thought-out recommendation, one we know works because we've tried it, is more welcoming and more helpful. And when we're really helpful and welcoming, everyone benefits. We get newcomers with a different perspective, with different experience, and all of that feeds into a richer community, where we can all learn, where we can all grow, we can challenge the norms and make the community stronger together. It's stronger from the point of view of the code we write, but more importantly, it's stronger from the point of view of inclusivity and being welcoming and getting more diverse. So when we have diverse backgrounds, different expectations, different experiences rather, different areas of expertise joining our community, we all benefit. That mixture drives innovation. Those varied perspectives and passions push forward the community, and we're all stronger for it. Well, maybe all gophers everywhere is pushing it a little bit, but you get my point. Let's change the default advice. Since 2013, I've moved from saying, just use the standard library, to saying, hey, we use this library, you should check that out. So let's think before we answer the question of what library to use. Let's review what we actually use and recommend that. Now, it may be that the standard library is the answer, but it may be we're also using some other library or package. It may be we've developed a library or small package that we could open source. Well, let's do that. Just because the question can be answered using only the standard library doesn't mean it should be. Let's use this great language to make this awesome community even better. This is one area where we can all feed back into Go. We can all become Go community contributors. The people of Go, or the people of Go's community are Go's greatest asset. Let's keep it that way. Well, thank you very much for your time and for listening. Any questions, I can take them now or over a beer later, or Twitter or Slack is always good.
Yeah. If you have any question, just raise your hand and I will give you a microphone. Yeah.
Hello.
Hi.
Great talk. Thank you. What do you think about having a centralized package manager versus this decentralized way that it is now?
Good question. In terms of the way it is now, we as a team have just moved into the whole kind of Go mod world. And I really like that. So as I said, a personal opinion, I think the way Go's kind of moving towards doing it actually makes a lot of sense. There's going to be some gotchas, there's going to be some hurdles that we're all going to have to figure out. And then I suppose things like Athens, you come across the Athens project, that's kind of a really great way of sort of bringing some of the benefits of both ways together into one thing. I'm not sure if I'm addressing your question. But yeah, I think the way Go is doing its kind of package management, its dependency management now with the Go mod world actually is a positive move and is making a lot of sense.
Sorry, I was saying that at the moment everything is decentralized in the sense that all the packages are on GitHub and other sorts of repositories. But how would it be if we would have everything centralized and managed by an entity?
Yeah, I think based on my experience with other languages like Java or what have you, where there's some of that kind of mishmash of things going on, I think the way Go is doing it, I prefer. So as a personal opinion, I think the decentralized approach is better, but that is a personal opinion, and everybody can have, different one. I don't think there's need to have a centralized repository for all of that, where everything goes in. So yeah, I think the way Go's doing it is actually really positive and really simple. The tool chain around it with like Go Get and all the other things just sort of makes that work without you worrying about it, which I really value.
Hello. Thank you so much. And my question is about security. You know problem package manager like NPM. And do you know a way how we can improve security when we are using third-party libraries?
Wow, that's a great question. The short answer is no. No, in all honesty, I don't know how we would improve security when using third-party libraries. Yeah, we do some vetting of libraries before we use them, but that's not really security-driven necessarily. So yeah, that's a great question. I'd honestly have to go away, think about that, and get back to you. I don't have an answer off the cuff, I'm afraid. I'm sorry.
Okay, thank you. It was the last question. If you have any question, you can ask him in a after talk. And in 30 minutes, we will have a break, coffee break, so we'll have time. Thank you. Let's give Nathan a round of applause.
Thank you very much.
Thank you.